Okay, welcome back to the very last video lecture in CS 163 and 164. This last lecture, I know I had talked previously about doing a different type of sort, but we're actually going to go over bubble sort. And bubble sort is actually a really simple sorting algorithm. It repeatedly goes through a list and it compares the adjacent elements to see if they're in the right order or not. And they're going to swap those elements to put them in the right order. But the bubble sort goes through the list as many times as it needs to until the entire list is sorted. So let's take a look at what this looks like visually, and then we'll look at a little bit of code. And again, this is another one of those sorting algorithms that I encourage you to play with. Grab the code and put it into Eclipse, see how it works, and even go through it on paper and just kind of try to figure out what's happening as you trace through it. So let's jump in here. When we look at a bubble sort and we have this list, so we're going through the first pass and we're going to go through each of the elements in that list. So here we can see in the very first pass, we have 5, 1, 4, 2, and 8. And we can automatically see that 5 and 1 are in the wrong position, especially if we're doing it in ascending order, which is from smallest to largest. So what we're going to do is we're going to go ahead and swap that 5 and 1 because 1 is less than 5. 5 is greater than 1. And then we're going to compare 5 and 4. Now 5 is greater than 4, so we're going to go ahead and swap those. And you can see how it's kind of bubbling up. That larger number is bubbling up to a higher position. And so you can see that now we're going to compare 5 and 2, and 5 is greater than 2, so we're going to move 5 up. And then we're at the last iteration of this pass, and we're going to check to see if 5 is greater than 8, and it's not, so we're going to stay there. We're going to go ahead and go back through the loop again. In the second pass, we can see that 1 and 4 are in the correct position, but then when we go to the next two adjacent elements, then 4 and 2 are not in the correct order, so we're going to swap 4 and 2. So we're getting a little closer, right? So we started out with 5, 1, 4, 2, 8. We ended the first pass with 1, 4, 2, 5, 8, which is still not quite close enough. And now we're in the second pass and we just swapped 4 and 2, and now we're at 1, 2, 4, 5, and 8. So the bubble sort is going to keep going through that second pass to make sure that everything is in order. But what's going to happen again is actually, even though we know that the array is already sorted, the bubble sort doesn't necessarily. So the bubble sort is going to go back through and make one more pass and make sure that everything is in order. And so it's going to go back through and make sure, and we see that it's all in order, and it's going to go ahead and return the sorted array. So another visual for bubble sort, again, we're going through the array multiple times, going through the list multiple times in order to put the list in ascending order. So you can see a similar situation as the one that we had before. It's just set up a little bit differently visually. So again, we're looking at the first two elements of the array, 2 and 9. They're in order. So we're going to go to the next two adjacent elements, which are 9 and 5, and those are not in order. So we're going to go ahead and swap those. The next two elements would be 4 and 9. And again, we need to swap those so that the 4 is ahead of the 9. And that 9 is just going to keep bubbling up until it is in the farthest right position for this array. If there had been maybe something higher than 9, then it would bubble up to where it needed to be within that array. Okay, we're going to go through again the loop, going through the second pass, go through the array again. 2 and 5 are in the right order, but 5 and 4 are not. So we have to swap those. Now we're comparing 5 and 8. Those are in the right order, but then we're going to compare 1 and 8, and those are not in the right order, so we need to swap those. So again, we're going to go back through again in a third pass, checking to see, once again, that 1 is going to bubble down until it comes into the 5th pass and it's in order. It's going to go back through, make sure that everything is in order, and then return the sorted array. So this little piece down at the bottom of the slide, the bubble sort time, that's our big O notation for bubble sort. And we're going to talk a little bit about that at the end of the bubble sort lecture. Okay. And here is the code for a bubble sort. So we're creating this method called bubble sort, and we're passing in an integer array in this case. And we have a nested for loop, so we're going through that array multiple times in order to do those swaps based on that condition if the adjacent element is bigger or smaller than the one that we're comparing it to. So it's a pretty simple algorithm, right? There's not a lot of complexity here. It's just a nested for loop, something you've seen before. It has a condition within that nested for loop that's checking adjacent elements, and then it's going to swap based on that condition, or it's going to go to the next set of elements. Okay. So again, grab this code, play with it, go put it into Eclipse and even trace through it. This is a really good opportunity to understand and learn bubble sort, which is one of the simpler sorting algorithms, and something that is easier to get started with in searching and sorting algorithms. So here is the bubble sort animation that I've had in previous slides, and you can take this URL and see it, how it's visually moving and sorting that array on the website. So it actually goes through the whole process and bubbles those larger items to the right and the smaller ones to the left. So I promised that we would talk a little bit about complexity. I'm not going to spend a lot of time on this because you're going to be getting a lot of this in CS 165. And even later on in your algorithms classes and some of your other classes too. But just know that big O complexity is a way for us to determine algorithm efficiency. And so when we looked back at the bubble sort time, you can see that it's O n to the 2. And if you look at the complexity here, you can see that O n to the 2 is actually not very good in terms of time. So it's actually going to take quite a while. It's not very good on the time complexity chart here that you can see, because the bubble sort is going through the list multiple times. I put the URL for the Big O cheat sheet here so you can kind of review that and just take a look at it, but you don't need to know Big O complexity in depth for this class. Just know that it's a way to compare algorithms and determine efficiency of those algorithms. So that concludes the video lecture series for CS 163 and 4. I've enjoyed spending time with y'all, even online, and I've wished that we could have spent a little bit more time together in the classroom, but I hope that everyone is doing well. Please reach out if you need anything to me or Ben, and yep, good luck with everything, and we'll hopefully see you all in the fall.